Hi everyone, and thanks for joining me today to talk about building motion-controlled websites in JavaScript. But before I start and dive into the topic, my name is Gerard. I'm a senior front-end developer at Netlify, but on the side, I'm also a Google developer expert in web technologies and a Mozilla Tech speaker. If you've never heard of these two things before, they are two community programs run by Google and Mozilla for people who like to share knowledge in the community. If you're interested in knowing more about it, feel free to ask me afterwards or on Twitter at devdevcharlie, and I'd be happy to tell you what it's all about. But today, what I would like to talk about is motion control. So motion control is a type of human-computer interaction. Before diving into only motion control, I want to talk about a few different interactions that you are probably very familiar with. First of all, interacting with the keyboard. Especially as developers, we spend most of our day on the laptop, so we use the keys on the keyboard or the trackpad to interact with interfaces. A second one that you're probably very familiar with is touching the screen, a touch screen. So either on your phone or on your iPad or on your smartwatch, you interact with these interfaces by swiping or double tapping for certain types of interactions. Another one that some of you might be familiar with is voice commands. Some of you might have a Google Home or an Amazon Alexa, or maybe you even built your own IoT device. And to be able to interact with this, you would say a certain command and you would ask for information about the weather or the news, or you would set a timer and things like that. So you interact with a certain interface or information using your voice. But the type of human-computer interaction that I want to talk about today is more of a motion control. So even in motion control, there's a few different ways to achieve this. One type of motion control is with wearables. So in this example here, I was wearing the Mayo armband, which is a device that you wear on your arm that senses the electrosignals that happen in your muscle as you move your arm. And as it detects gestures, you're able to send this information to your computer to then have interfaces that would react to gestures. So that type of motion control is using some kind of biometric data to interact with an interface. Another type of motion control is with external hardware, is something that you would plug to your computer, like the Leap Motion. The Leap Motion is a device that you plug into your computer that has an infrared camera inside, so it's able to recognize different parts of the finger over it, of the right hand and the left hand. So you're able to use that information to interact with interfaces either on the laptop with a game, or just by scrolling up or down with movement of your hand, or also now in VR, as the Leap Motion is used with the Oculus Rift as well. But the type of motion control that I'm really excited about is with using built-in hardware. So on the left here, you can use your accelerometer and gyroscope that is inside your phone to interact with interfaces as well. And you can have access to this data in JavaScript with some web APIs that allow you to have access to the accelerometer and gyroscope data. But the most exciting thing for me at the moment is the use of the built-in camera to do motion control. And I want to dive a little bit into different tools that are available at the moment to do this. So let's dive into the tools. I'm going to talk about three different ones. The one I'm going to start with is called PoseNet. So as you can see in the GIF here, you can do pose detection. So it recognizes some kind of skeleton of a person in front of a camera, and you can use this data to interact with interfaces. You have a few different key points that you have access to. So if you want, you can pick only the movement of the shoulders or the movement of the elbows or the foot, or you can use the entire body if you want as well. But let's look into how you would actually implement that in code. The first thing you need to do is to load PoseNet into your application using posenet.load, in which you pass in a few different parameters. Personally, I only use the default parameters that was in the README of the demo in the repository, but feel free to play around with the different values. After PoseNet is loaded, you can go on and set up the camera. So here I'm calling my load video function, because what PoseNet is going to do is going to use the data that is in the webcam feed to recognize poses or body shapes. And then once we have loaded our PoseNet model and our camera, the webcam feed is ready, we can call our detection function. To set up our video feed, here I'm calling my setup camera function, and what it does is going to call the get user media to have access to the built-in hardware of the microphone and the camera. In certain examples, I actually don't want the audio feed, so I'm setting the audio to false, and I'm setting a few parameters in the video to have access to the camera. And finally, we can call our detect function that is going to take that video feed, and we are calling the estimate single pose method on the net, so the PoseNet object, We passed it a video and a few different parameters, and what this is going to do is going to try to find the key points of our body shapes in the camera feed and store that into a poses array, so that then what we can do with this is we can loop through the poses array. And if we are confident, if we have reached a certain threshold of confidence about the key points that we found, we can look through the key points of the body shapes that the model has found in the camera feed and look for the key points that we're interested in. In my experiments, I've often used the hand movements, so I've been looking for left wrist and right wrist in our list of key points, and if they exist, so if it is found in the camera feed, we have access to the position property on the left wrist object, or right wrist object if you want, and that gives us an x and y coordinate relative to the size of your window. A side project that I've built using this framework is called Beat Pose, that uses a clone of Beat Saber in the browser that you can play with your hand movements. So the whole idea was that I like playing Beat Saber, but I don't have a VR headset and I don't really have the space to set it up, and it's quite expensive. And I wanted to be able to have the kind of same interaction, but with the material that I had, so basically a laptop. It looks for the key points of my left wrist and right wrist, and it interacts with the game just using my body movement. The second tool we're going to talk about is called Face Mesh. So it is another tool that is developed by Google that allows you to find key points in the face as well. What is different between Face Mesh and a few other JavaScript libraries that allow you to do face recognition is that this one has an element of a third dimension. Instead of just trying to figure out if there is a face in the camera feed, it also kind of follows your face around as you move in certain directions. So it's not only a bounding box between like that recognizes where the face is, it kind of really, you can really do some kind of like face mask or like Snapchat filters with it, because as you move your head around, the key points follow in X, Y, and Z axis. And the code to implement this looks like this. As this model also uses data coming from the webcam, we would have to call our load video function the same way that we did in the previous example. Then we would move on to set up the backend that we want to use. Personally, I've been using WebGL, but I know that there's also WebAssembly, I think, that you can set. And then we would go on to loading the face mesh model. And once this is done, we would call the estimate faces method on the model, and we pass it the video HTML element. And if it finds any kind of face in the feed, we would go into that loop, and then we would be able to loop through all of the data that goes in the prediction to be able to find the key points and build whatever experiences we would want with it. And then we would have to call again request animation frame, calling the same function to be able to get constantly the data, new data coming from the webcam, and find new key points or adapt their positions to our movements. So this is just a screenshot of what comes back in the predictions array if it finds a face in the webcam feed. So you have different properties like annotations. So you can see that annotations is a list of different parts of the face that you can have access to. Then you also have bounding box with the bottom right and the top left, so coordinate of where your face is in the camera feed. And then you also have access to a mesh if you want to do 3D experiments or 3D masks and things like that with the face that the model has found in the camera feed. So here's a small demo of something that I built using the face mesh model that I called face scroll. It basically allows you to scroll web pages or documents by tilting your head forward and backward. So it uses the webcam feed and the face mesh model to recognize the coordinates, the Z coordinates of certain parts of my face, and as they change, I indicate that I want to scroll up or down. So I thought it was pretty interesting because it would work even if you're further away from the screen. So if your hand can't access the keyboard or the trackpad, you can use this. Or if for some reason you can't really use your hands, you would still be able to interact with web pages just by tilting your head. And finally, the third tool that I want to talk about is called hand pose. So as you can see in the GIF here, it recognizes certain parts of the hand. So instead of just recognizing only if there's a hand or not in the feed, it also recognizes key points of the hand. And as you can see here, it also has some kind of like Z axis because it can recognize when fingers are folded, which is really impressive to be able to do in the browser. So how would you go about implementing this? So what's kind of cool with this is that as hand pose is also a model created by Google, it means that the syntax to be able to implement it is quite similar to the two previous ones. So we would have to start by loading the video again. And then I set my backend to WebGL the same way as I did with face mesh, but then I load the hand pose model. Once the model is loaded, I call the estimate hands method on the model, and I also pass the video element, and we end up with an array of predictions, and we repeat the same code that we did before. So if we found certain predictions in the camera feed, we're able to loop through the key points and find the data that we're interested in. So now that I talked about the 3 different tools that you can use and how to implement them in your code, I want to talk about the few different applications that you can build with this. So where I see a lot of opportunities is in accessibility. A lot of the times when we talk about web accessibility, we might only think about vision impairment, but there's actually a lot of a broader spectrum of different situations in which users wouldn't be able to use the web easily. If we look at the temporary touch impairment, like the arm injury, it is something that can happen to anybody. That type of injury can be really disturbing in the way you use the web day to day. If you're right-handed and all of a sudden you break your right arm, you would have to learn how to interact with the web with your left hand by using the trackpad and the keyboard, but it's something that could be quite annoying because you're not used to it. If we were thinking about integrating face mesh and hand pose into our web applications, we might allow people with temporary difficult situations to interact with the web in an easier way. With my example of being able to tilt your head back and forth to be able to scroll, it means that even if I'm far from a screen, or even if I'm doing something else and I don't want to touch my keyboard and my trackpad, or if I broke both of my arms, I'm still able to actually scroll a website with more of a natural interaction. But when I'm talking about integrating face mesh and hand pose into our websites, I'm not talking about it as being the only interaction. I was more thinking about it as the same way that we integrate dark mode. At the moment, dark mode is not the default, but it's an option that the user can trigger if they decide to use it. And I would think about motion mode the same way. It's like as if you interact in the website on a normal day, you could still use the keyboard and the trackpad, but if, for example, you end up being far from your screen for 5 minutes, or let's say you're eating a sandwich with your hands and you don't want to touch your keyboard or your trackpad, you could just trigger motion mode and being able to interact with motion just for a few minutes if you want to. Another opportunity and application that I really believe in is to have more natural interactions with interfaces. So in this particular GIF, this is an example in VR, but if you look at it and the recognition of the hand that the Leap gives here, we could have the same kind of recognition with the hand pose model. Here, there's not that much 3D involved, there's more recognition of fingers. So we could think of it as, can you imagine if you could just build a website by creating divs just by stretching your fingers like this, instead of having to code it and set a width and a height in your code, you could allow people to just build a few different layouts by doing this. So I'm not saying that this is something that it's totally going to replace the web, but I'm just thinking about different ways to interact with interfaces. Personally, typing on a keyboard or swiping on the trackpad that only has like a certain size, I don't find it very intuitive, and I would love for this kind of technology to actually push people to think a bit outside of the current layouts that we have. And finally, a third application I could think of was in health and fitness with the device that I showed in this slide called Mira. So what this device is, it's kind of like a personal trainer at home in the shape of a mirror, and it shows you different exercises that you're supposed to do, and it does body tracking to check that you're doing them properly and for the right amount of times, etc. So it's really like a coach, like an AI coach for fitness. What I think is really interesting here is that we have to remember that JavaScript is not only for websites in the browser or on your phone, it's also for Internet of Things. And that kind of mirror here can be done at home if you want to build your own. It's usually a screen behind a two-way mirror, and you can use a camera and models like hand pose and face mesh and PoseNet to actually build that kind of experiments at home as well, where you can have JavaScript being your fitness coach, and you can use machine learning models to make sure that you're doing the exercises properly. So I think that's pretty exciting. Of course, I only talked about 3 different applications here. That's the ones that I could think of, but there's probably a lot more, and I would love for people to think about how these kind of models in JavaScript can be useful to them. And then finally, I would like to talk about the limits, because even though I'm really excited about that kind of technologies and the possibilities, I think it is important to be aware of the limits if you decide to implement that in your application. applications. So the first limit that we need to think of is performance. These two models, so FaceMesh and HandPose, have only been released a couple of months ago, so I really believe that Google is going to work on making them even more performant. But FaceMesh is about 3 megabytes, which in a way, to be able to do that kind of like 3D face recognition in the browser is pretty good. But in terms of frames per second, the maximum, the most performant that it can get to is 40 frames per second. And a smooth animation usually on the web is about 60. So what's going to happen is that it's still quite performant, but it means that as you're moving your head, there might be a little delay between the key points that the model finds in the camera feed and the real movements of your face. So depending on what you want to build, you have to take into consideration that delay. With HandPose, the model is a lot bigger. It's about 12 megabytes, so it will definitely impact the performance of your web page. But again, it's not because you're not going to use it in production that you shouldn't check it out at all. I still think it's really worth it, and I really do believe that Google is going to work on making it smaller and smaller. In terms of frames per second, it's the same as FaceMesh. The maximum is 40, so there is going to be a little delay. But depending on what you want to do, it might not actually, the delay might not actually matter. Another limit I could think of was in terms of accuracy. You have to remember that we're using the laptop's webcam, which is not a depth camera. So that's why I'm really impressed that with models like FaceMesh and HandPose, we still have access to that Z-axis, that kind of feeling of depth of the key points that you get from the data from the camera feed, but it's still not really a depth camera. So there is always going to be a little issue with maybe accuracy, but again, depending on what you want to do, it might not be a problem at all. The other thing with accuracy is lighting. As it is computer vision, if you're not in a space that is well lit, you will lose some accuracy in the data that you get as well. And then finally, user experience. There's always a concern about privacy when we're tracking users constantly, and that's normal. But at the moment, people seem to be comfortable with an Amazon Alexa and a Google Home tracking what they're saying all the time. So maybe we could think that that kind of interactions using the webcam could actually become more and more accepted, as long as maybe you reassure the user that the data from the webcam is not saved anywhere. It's just used for recognition of the interaction, and that's it. The second element in terms of user experience would be learning a new way to interact. But I'm not really concerned about this one, because I really believe that if we find a way to provide an extra value to interacting with interfaces on the web using motion, I really don't think that people will be reluctant to trying out motion. We have to remember that we got used to touch screens, so why not motion control? A few years ago, when people didn't have touch screens, we only interacted with our old mobile phones by typing on these tiny keyboards, and as soon as more and more touch screens came out, we understood, or we learned how to actually use them. We learned what it was to scroll up and down. We learned how to zoom on our screens. That was not a really intuitive interaction before. We didn't know how to do that before we actually had to with touch screens. So I really don't think that motion control is very far away. I think that it needs to improve a little bit in the browser to allow to create performant experiences, but I think that it would be really interesting to just rethink what the web would be if we could interact with other things than the keyboard and the trackpad. So that was it for my talk on building motion-controlled websites in JavaScript. Thank you so much for joining me, and thanks a lot HalfStack for letting me talk about that. And if you have any question, feel free to ask me afterwards or on Twitter at devdevcharlie. Thank you.
Go ahead, we're live.
Hey, so that was a brilliant talk, Charlie. Thank you very much for giving that. I'm sure everybody here learned a whole load of things and will be busy diving into JavaScript libraries at the moment. So we just got a couple of follow-up questions for you. I'll hand you over to Joe to kick us off with the first question.
Oh, thank you, and thanks so much, Charlie. That was a really good talk. I really loved that. So if, let's say, the world of any possibility, anything that you could use to interface with a web browser today, what would you use?
You mean if any kind of interaction? If it were not based with the camera but just anything?
Yeah, anything.
What I'm working back on at the moment is I'm going back to, because I used to play around with brain sensors and being able to interact with the browser using your brain waves and stuff like that, but I paused for a bit. And now that I got a newer brain sensor, I'm going back into that as well. So I'm thinking about what kind of interactions we could have with the web if we could use our thoughts and not even our movements or anything. Like what would be possible with the state of technology that is at the moment. Because with brain sensor technology, it's not about being able to track whatever thought you have. It doesn't work like that. But knowing the limitations at the moment, it's like, what can we still do with it? That's what I'm diving into.
I love that. I love the idea of browsing at the speed of thought.
Yeah.
That's really cool. I do like that idea. So does that mean we'll be able to deploy to Netlify just by thinking about it at one day?
I am working on trying to do that as a side project, but just being able to think like push, and it would just push to Netlify.
What was it that got you interested in HCI in the first place? What led you down this path?
I think it goes back to when I finished my bootcamp, when I learned to code, and I had a bit of time when I was interviewing, and I started at the time, like about 6 years ago, to play around with little robots and how I can use JavaScript to control these robots. And as soon as you use JavaScript to do something like physical and not in the browser, then all of a sudden it is all about interacting between your code and a piece of hardware. And then I just, the first little line of code, they say turn a light on or something, then all of a sudden it's like, well, what else can I do? I can use like hand motion or other kind of body movements, and then you kind of you experiment with different types of inputs. It could be a motion sensor or the camera or the Mayo armband that I talked about in my talk, where it senses the activity of the muscles and you recognize certain gestures, and then it kind of opens all that world where you think that about the keyboard and the trackpad, and it's like, is it really what we're using? Like, there's so much more that we could do, and we just like get stuck on this little keyboard thing. But I find that really fascinating, because as soon as you dive into this, it really opens a world of possibilities, and it also becomes frustrating because you're like, why are we not diving more into this? This is like so interesting. But yeah, it started like gradually, and every time I look into a new piece of hardware, I kind of start thinking about, okay, what else? What else is there? What can we do? And I also read a lot of research papers about HCI, and then I try to think about, okay, this is just research, but can I do that in JavaScript? Also, trying to do it in JavaScript is a bit difficult sometimes, but yeah. But well,
is there anything you've not been able to do in JavaScript?
Sorry?
Has there been anything you've not been able to do in JavaScript?
I think so far I've always gotten to a point where I built a prototype that I was happy with. It's like I know that most of the times in the research papers that I read, either they implement it in like Python, or sometimes it's just an idea and they haven't actually implemented it or something. So I think so far I always got to a point where my prototype was good enough just to validate an idea, but I didn't push it to the point where I would want to like really release something that's robust. So it's always a bit like flaky, but that's the point. It's just I'm just trying to validate an idea. I'm not trying to build something that would be really robust. So far, I think I've been lucky, or maybe I have pushed away some ideas that I know might not be possible to do in JavaScript, and then it means I'll have to go into maybe C++. But yeah.
Eventually, Atwood's law will win, and it will be possible in JavaScript. It just takes time.
Yeah. Well, you can. I mean, if you can do brain sensor stuff in JavaScript, I don't really know what else. Nothing can stop you now. But
that's right.
And if anyone who's listening is wanting to get into HCI, where would you recommend they start to look?
I think maybe because HCI is so broad, maybe trying to focus on starting with one interaction. First of all, maybe think about, do you want to use a piece of hardware that you already have that has a sensor in it, or do you want to use the camera? If you want to use the camera, I think that the whole, the few different libraries that are developed by Google in Tensorflow.js are pretty good, and it means you don't have to buy a piece of hardware. You can interact, you can play around with that in JavaScript, so code that you already write, you just have to, you have to learn a new syntax for a new framework. But if you want to, if you have a piece of software like a Leap Motion, or even if you have a Nintendo Switch, they have the controllers, and you actually have JavaScript libraries to interact with the hardware that's in there as well. Usually I look on GitHub and I try to see what's already there. I try to see if other people have tried to do the thing that I'm doing, and otherwise I start with either a sensor that I picked or a built-in camera thing, and then I go from there and I try to see how do I access the data from that sensor.
Awesome. And is there anything coming in the future that you're particularly excited about?
I think I was thinking about something and I totally just forgot. But I think I'm excited about the fact that you can now also run TensorFlow on some pieces of hardware like a Raspberry Pi and an Arduino, because it means that you can really build your own little kind of IoT device at home and leverage the power of machine learning. So you can really mix hardware and machine learning all in like a small device and all in JavaScript. And I find that really super exciting. I don't really have an idea right now, but mixing all of these pieces together, like hardware, HCI, and JavaScript, and machine learning is just, I mean, the possibilities are just like super exciting.
So I often joke that I want to get a thought computing device and a robotic dog and think bark and make the dog bark, because my dog just barks whenever it wants and never shuts up. And I want to make the dog only bark on command. So I think that would be pretty fun.
Why not? I'm
right.
sure it's possible.
That's my future HalfStack dog. I think we have time for maybe one more question. So how have you been dealing with just sort of the whole COVID-19 stuff and being at home, and what's that been like for you?
I don't think I'm very good at dealing with that at the moment, because so I work at Netlify and it's my first remote job. So I was already not really good at having a break between my workday and my life. But now that I'm stuck at home in Amsterdam and I just moved here, like I don't know how to have a break. So I'm working all the time basically, which is not good. I really don't recommend doing that. I'm trying to find a way to change my schedule a bit around, but it's just been like working truly full time.
Yeah, because there's no travel time, there's no downtime. It's just like, I'll just work again today. Every day's Monday. Yeah.
I can't wait to go hiking and see nature. Yeah.
Awesome. Well, thank you so much, Charlie. And
thank you so much.
The video will be linked online soon. And up next is Gillian.